All right, so we've been discussing trigonometric functions and using the unit circle to efficiently evaluate trigonometric functions. And just to review the trig functions, we know that sine of theta refers to the comparison of the opposite side to our hypotenuse. And the cosine refers to our adjacent side compared to our hypotenuse. And using our unit circle, we saw that our opposite side was often, or not often, always equivalent to our y value. Our adjacent was equal to our x, and our hypotenuse was equal to our radius, with the unit circle with the radius being 1. So using these variables, we can rewrite our 6 trigonometric functions as y over r, cosine as x over r, tangent as y over x. I'm just going to zoom in on this. That means cosecant then can be written as r over y, it's reciprocal, r over x is secant, and x over y is our cotangent. So with that in mind, let's go ahead and let's try to find the values of 6 trigonometric functions if we're given only information about the side lengths of a triangle. So suppose this is my angle theta. You'll notice I don't know what theta is, and honestly, it doesn't matter. Because if I wanted to say, let me see if I can write this, sine of theta, cosine of theta, tangent of theta. We have, this would be cosecant of theta, secant of theta, and cotangent of theta. And you know what? I'm going to probably need this a couple times throughout the lesson, so I'll just copy that. So if we're finding the sine of theta, I don't know what theta is. I don't know what my angle is, but it doesn't matter. I know that sine is equal to my opposite over my hypotenuse. So I can just say my opposite side here is 2, and my hypotenuse is 4, which simplifies to 1/2. All right, what about cosine now? Well, cosine, I need to compare my adjacent side here, which I can label as x, over my hypotenuse. Now that adjacent side was not given, but if it's a right triangle and I know 2 of my sides, I can use the Pythagorean theorem. I can say that 2 squared plus x squared is equal to 4 squared. So x squared is equal to 16 minus 4. So since we're dealing with the side lengths of a triangle, I can say x is simply equal to root 12 or 2 root 3. Now that I know that this side is 2 root 3, I can go ahead and write my adjacent over my hypotenuse as 2 root 3 over 4, or root 3 over 2. Tangent then would be opposite over adjacent, so 2 over 2 root 3, which simplifies to 1 over root 3, which fully simplifies if I rationalize to root 3 over 3. Okay. Cosecant of theta is simply the reciprocal of sine, so that's 2. Let me actually just move this a little bit to the side so we have some space. Cosine of theta is equal to 2 over root 3, which rationalizes to 2 root 3 over 3. And cotangent of theta would be 3 over root 3, which simplifies to root 3. Okay? So we'll see here that oftentimes we can evaluate trig functions as long as we know just the side lengths of our right triangle, because trigonometry is the study of side lengths of a triangle compared to their respective angles. So go ahead right now, pause the video, and see if you can work through this next problem here. Okay, so if you've had a chance to work through it, hopefully we see that if we're finding the cosine of theta, then I can just draw any arbitrary triangle here. If my adjacent side is 3 and my hypotenuse is 7, I can again use the Pythagorean theorem to find my opposite, or my y. So I can say 9 plus y squared is equal to 7 squared, which is 49. Y squared then is equal to 40. Y then, in the context of a triangle, has to be 2 root 10. So using what I know, I can just go ahead and write these out. Sine of theta then would have to be 2 root 10 over 7. Cosine would be, well, that was given to us. This is 3 over 7, which means it's a reciprocal of 7 over 3. Tangent would be 2 root 10 over 3. And the reciprocal of that for cotangent would be 3 over 2 root 10, which we can then simplify to 3 root 10 over 20. And cosecant would be 7 over 2 root 10, which we should rationalize to 7 root 10 over 20. All right. Now, I want us to review our understanding of our trig functions and their relations to the unit circle. That is to say, if you've memorized your unit circle, you should be able to use those x and y values to fill out this table pretty quickly. Pause the video right now and try that. And hopefully you were able to pretty quickly write these out. And if not, continue to just memorize your unit circle. And you can watch back to my previous videos if you need guidance again as to how to work and find those values. But after doing that, we should hopefully see that these are our values here for the units that, remember, our sine correspond to our y values, our cosine correspond to our x, and the tangent would be our y over our x. Now, I want you to pause and ask yourself, do I see any connections between my sine and my cosine? My sine and my cosine. Do I see any connections here between these values? And hopefully what you are finding is that sine of 0 gives me the same thing as cosine of 90. Sine of 30 gives you the cosine of 60. Sine of 45 is equivalent to cosine of 45. Sine of 60 is equivalent to the cosine of 30. And the sine of 90 is equivalent to the cosine of 0. Specifically, look at these angles. Sine of 30, cosine of 60. Sine of 45, cosine of 45. Sine of 60, cosine of 30. Sine of 90, cosine of 0. And I should also do this as well. Now, do we see the relationship a little bit more clearly? And hopefully what we're able to say is that, yeah, the sine of any angle is equal to the cosine of the complement of that angle, right? Sine of 30 degrees is equal to the cosine of the complement of 30 degrees, which is 60. And if I wanted to further write this mathematically, I can say that the complement is simply pi over 2 minus theta. Why is this so important? I want to reiterate here that the sine of theta is equal to the cosine of the complement of theta. Complement, which would refer to cosine, the complement of sine. That's why we call this the cosine function, because it refers to the complement of its angle, right? Wow. I'm hoping, and I'm guessing, and I'm assuming right now that this is your face, that your mind is blown right now. That's where we get the names of these trig functions. And we could take that a step further. We see all of these trig functions have a cofunction. Sine is cofunctions with cosine, tangent and cotangent, secant and cosecant. This is what we refer to as the cofunction identities. An identity is simply any equation that is always true for whatever value you might plug in. We've already seen some identities with trigonometry, such as the quotient identity, or the reciprocal identities, I should say. Speaking of the quotient identities, we know that since tangent of theta refers to our opposite over adjacent, or y over x, and we know that sine is always equal to y, and the cosine is always equal to x, we can say that tangent is simply the same thing, or equivalent to sine over cosine. Okay? All right, so I'm going to let you go ahead and work through these problems on your own. You can check your solutions with what I have uploaded to my website. And hopefully this video has helped work through a few of these. I'll do one more before I leave you today. Let me just go jump to this last one right over here, just to make sure that we understand how to evaluate these. If we know that the secant of theta is equal to 5, and the tangent of theta is equal to 2 root 6, I can then say cosine of theta is equal to 1 over the secant of theta. So this would be 1 over 5. Cotangent is 1 over the tangent of theta, or the reciprocal of tangent theta. So that's 1 over 2 root 6, which we should rationalize to root 6 over 12. Cotangent of 90 minus theta, that is a cofunction with tangent of theta. So since we know what tangent of theta is, we can just say this is 2 root 6. The sine of theta, well, this one might be a little bit less clear, but we know that tangent of theta is equal to sine over cosine of theta, which means sine of theta is equal to cosine times tangent. And we know each of these. This is 1 over 5. This is 2 root 6. So we can say this is 2 root 6 over 5.